All right, hello everybody. This is Unit 5. We're dealing with quadratics in factored form. What we're going to learning objective in this video is I can find critical values of quadratics in factored form to graph them in the coordinate plane. All right, so let's take a look at two problems of a quadratic function in factored form and how we're going to find the critical values to help us graph it. The critical values are going to be our x-intercepts, so where these parabolas are going to intersect our x-axis, and also the maximum or minimum value. So if our parabola is up like this, goes kind of in this shape, then we're going to have a minimum point down here. If our parabola is like this, then we're going to have a maximum point up here. So we're going to find those points, the x-intercepts, and then either the min or the max, wherever they may be. All right, so we have this first equation here. F of x is equal to x minus 4 times x plus 6. And what we're going to do is find the roots. It's called the roots or the x-intercepts, kind of the same thing, but it's very commonly called the roots when it's the points that cross the x-axis. And how we're going to do this is, since we know we're crossing the x-axis, say our point is here, anywhere on this x-axis, we know that our f of x, right, our f of x value is going to equal 0, right, because it doesn't have any height. It's not going this way or this way. Our f of x is going to be equal to 0. So we know that f of x is equal to 0. Now, since we know f of x wants to be 0 for our x-intercept, and this is basically multiplication here, right? We have x minus 4 is getting multiplied by x plus 6. And I know that in multiplication, if I can multiply something by 0, then I will get 0, right? Anything times 0 is 0. So the goal is to make one of these two things in the parentheses here equal to 0. And that will guarantee that f of x will equal 0 as well. All right, so let's take a look at an example. If we want x minus 4 to equal 0, then we need to figure out what x is equal to. Well, if x minus 4 equals 0, then if I add 4 to both sides, then x is going to equal to 4, right? So I know if I put in x is equal to 4, then 4 minus 4 is 0. And 0 times anything is going to make 0. So I know that x equals 4 is going to be one of our x-intercepts. So when x is equal to 4, I know that f of x is going to equal 0. So I'm going to plot that point right here. 1, 2, 3, 4. All right. Likewise, when I plugged in x is 4, I made this 0. I made the whole equation equal to 0. I can also make this a 0 also. So x plus 6, I can make that equal to 0. If I subtract 6 from both sides, I will get x is equal to negative 6. So if I plug in x here, if I make this a negative 6 plus 6 will make a 0. 0 times anything here will make 0. That's what we're going for. We're trying to make f of x equal to 0. So if I can make a 0 here or make a 0 here, that's what I'm going for. That's good news. So when x is equal to negative 6, I know f of x is going to equal 0 as well. So let's go back to our function. If x is equal to negative 6, so 1, 2, 3, 4, 5, 6, f of x is going to be equal to 0. All right, so I know my function is going to go through this point here and this point here. And I know that parabolas are symmetrical, right? So I'm going to draw a little sketch of a parabola here. this is symmetrical, right? Let's just say it crosses the x-axis here. The halfway point between the intercepts is going to be this minimum value down here. Okay, so this halfway point, halfway between here, is going to give us our third critical value. All right, so let's find the halfway point in between here. We're at a -6 here. We're at a +4 here. That's going to be 6 and 4. That's 10 units in between there. So I know halfway would be 5. So 1, 2, 3, 4, 5. So my halfway point is at x is equal to -1. So what is my f of x going to equal when x is equal to 1? Well, let's figure that out. We have f of -1 is going to equal -1 minus 4 times -1 plus 6. This is going to equal -1 minus 4 is, that's a -5. -1 plus 6, that's going to be a +5. So when x is equal to 1, our f of x, this is a -25. So when x is 1, we will get a -25. That is really low. Why don't I scale my axes here and count by, let's see, 1, 2, 3. Let's go ahead and count by 5s. Why not? I'm going to make this -5, -10, -15, -20, -25. So when x is -1, we will be down to -25. And now we've kind of taken some shape for our parabola, right? So now I can kind of take my pen and do like a little sketch of what this parabola is going to look like here. There we go. So we found our three critical values, the two x-intercepts and the minimum. Let's do the same thing for a second function here. F of x is equal to -3 times x minus 6 times x plus 2. Again, we want to find the x-intercepts first. So we want to figure out where f of x is going to equal 0. We want to figure out where f of x is going to equal 0. And I'll give you a hint. There's going to be two of them, right? We're going to cross the x-axis 2 times. All right. Now, how do we find our zeros? Well, this is all multiplication, right? Remember, this is -3 times an x minus 6 times an x plus 2, right? This is multiplied by multiplied and multiplied. Everything's multiplied together here. So to make it 0, I need to make sure that one of these things are 0. Well, the -3 can't be 0, but this could be 0, and this could be 0. So the x minus 6, how are we going to make x minus 6 equal to 0? Well, x is going to equal 6, because 6 minus 6 is 0. All right, so I know that if I plug in x is equal to 6, this will turn into a 0, right? 6 minus 6 is 0, and it doesn't even matter what these are, because this times this times this will make 0. Likewise, this x plus 2, we want this to equal 0. So I know that x is going to have to equal -2 for this function f of x to be 0 also. So -2 will give me my other 0. So let's plot those points. All right, so x is equal to +6. 1, 2, 3, 4, 5, 6. There we go right there. And then x is going to be equal to -2. -1, -2 right there. All right, so those are going to be our two critical values right here. But we need a third critical value to make shape of this. We don't know if it's kind of long and kind of narrow or kind of wide like that, or really tall and skinny. We do know it goes through these 2 points here and here, but we don't know how high up on the f of x axis we are going to be. But we do know it's symmetrical. Again, it's going to be something like this. We hit at this point and this point. We know the halfway in between point will be this maximum up here. So let's find that halfway in between point. Remember, this was at a 6. This was at a negative 2, right? Yeah. All right, so halfway between negative 2 and 6, that's over 1, 2, 3, 4, right? And 1, 2, 3, 4. So our halfway point is at a positive 2. So let's figure out how high we go when x is equal to a positive 2. Plug this into the original equation. F of 2 is equal to negative 3 times 2 minus 6 times 2 plus 2. Right? We just plugged our 2 in for x there. This is going to be equal to negative 3 times 2 minus 6. That's a negative 4. And 2 plus 2 is a positive 4. Negative 3 times negative 4, that is a positive 12 times a 4, that makes 48. All right, so we know when x is 2, our f of x is 48. So let's count up. We got 5, 10, 15, 20, 25, 30, 35, 40, 45, 48. 50's up here at the top. 48's about right there. I definitely drew that f of x in the wrong spot. But that's how the world works sometimes. All right. We are going to go from our point here all the way up to our point, which is at 248. Remember, this is mostly just a sketch. And this is going to come down here. And this extends on forever. So until we found that third critical value of 248, we did not know how high this point was. So we couldn't make our parabola until we got our third critical value. All right. On the back side, there is some more for you guys to practice. All right. Thank you very much, and goodbye.